All right, in our review video this week, we are going to look at simplifying radicals, which we have already done, but we will use again in this week's lesson. So I want to make sure that we remember everything. Now, keep in mind that this concept uses what we know as our perfect squares. And so if we've forgotten our perfect squares, they're listed to 100, and we know that it goes beyond there, but these are the most common ones that we use. And so what we're looking at being able to do is take this radical and we want to simplify it using one of these perfect squares. And we talked in depth before about how this is called the zero product property. And so we take 45 and we think of all the factors of 45. And what we want to do is make sure that we rewrite this as a product of 45 that uses one of these perfect squares. So I'm going to rewrite this as 9 times 5. 9 times 5 is still 45. But now what happens is that when we take the square root of this, the square root of 9 is 3. 5 is not a perfect square, and so therefore stays underneath the radical. And there is our simplified version of the square root of 45. Now, when we look at the next one, the square root of 60, we talked about how there may be several sets of factors that multiply to 60. 2 times 30, 3 times 20. We have several sets, but we're looking for the set that contains the greatest perfect square factor. So we would be looking at 4 times 15. The square root of 4 is 2. 15 stays under the radical, and our simplified answer is 2 times the square root of 15. For number 3, we have the square root of 48. Now, this might be where you need to go and say, well, I know that 48 is 1 and 48, and 2 and 24, and 3 and 16, and 4 and 12, and 6 times 8. You may need to list those out. Everyone's kind of at a different level here. And we might even see that we see a perfect square here with 4 and 12. But what we're actually looking for is the largest perfect square, which would be 16. So when we rewrite this, this is going to be 16 times 3. The square root of 16 then is 4. 3 will stay under the radical. And the last one there is 200. And sometimes we just get in the habit of listing all of our factors, but we really want to make sure that we look at that number. And if we see 200, hopefully immediately we think that that is 100 times 2. And that the square root of 100 is 10, and the 2 will stay under. So I'm going to take now and flip to the next screen. And there are 5 problems there. And I want you to pause the video and on your own try those 5 problems. And when you are finished, start the video again. Okay, for number 5, we have the square root of 180. And I'm hoping that when we went to look for our perfect squares, that we were able to find that this is the square root of 36 times 5. And the square root of 36 is 6, and 5 will remain under. 75, we know that anything ending with a 5 that we want to try 25. So this would be 25 times 3, which is 5 times the square root of 3. 72. This is one we've got to be careful about, because a lot of times when students hear 72, they automatically think of 8 times 9, and 9 is a perfect square. But if you list out all the factors, we would see that we would also have 36 times 2 is 72, and 36 is a perfect square, which is larger than 9. So really what I want to use here is 36 times 2, and the square root of 36 is 6, and 2 will stay under. And then our last one is 98, and 98 is going to be 49 times 2, and the square root of 49 is 7, and then the 2 will stay under, so 7 radical 2. Now, if you feel that you're ready, then go ahead and take the weekly review formative assessment. If you feel that you have some questions, make sure that you come to one of the Zoom sessions.